here, and we capture them and then estimate the dose that we get. Next slide, please. We've recently developed a similar method for small mammals. It's hard to see with the lights on here, but this mouse here from Chernobyl, again, has a little collar on it with a TLD, which allows us to measure the external dose. Next slide. And we also have set up portable gamma spectrometry in the field so we can get estimates of the internal dose based on the whole body burdens. Next slide, please. Next slide, please. Next slide. And basically what we see is that we see a very good relationship between the background of radiation and the activity that we measure inside the bodies. Next slide, please. Next slide. So what are the developmental effects? Next slide, please. Next slide. Next slide. Next slide. The first thing we noticed was that many of the birds show patches of white feathers. They're partially albinistic. And again, this doesn't seem like it's a particularly deleterious kind of trait, but it was certainly unexpected. Next slide, please. Here's another example right here. And again, you might think that this wasn't particularly deleterious, but it is in the sense that these males are less preferred by females, and less sexy, as it were, as a result of these patches of white feathers. Next slide, please. You see strange aberrations in tail feathers. Next slide. We also see more serious things like tumors on beaks. Next slide, please. Patches of beaks, another species with some white feathers. Next slide. Here's a great tick with a tumor below it and above its eye. Next slide. Here's a nightingale with a tumor on its head. Next slide. Here's another bird with a tumor on its wing. Again, these sorts of things are just never seen, very rarely seen in nature. Next slide, please. And when you add them all up, after you've caught and investigated and examined many hundreds of birds, thousands of birds, we find that, again, a very strong relationship in terms of the number of partial albinos and the level of radiation and the number of tumors that are seen in these populations. And this is, again, these kinds of aberrant developmental effects are really only seen in any significant numbers in these areas of high contamination. Next slide, please. A couple of years ago, we also noticed that there were impacts on neurological development. For instance, the birds in Chernobyl, in the highly contaminated areas, have about 5% smaller brains. Next slide. And this is important because it seems to have cognitive impacts. The birds with smaller brains have a much lower probability of surviving from one year to the next. There are survival impacts as well. We've noticed similar impacts. We're starting to see similar effects in the mice populations that we've mentioned as well, which again is kind of interesting. Next slide, please. Another character that, again, we started to look at as a result of the Lysines motivations concerns the eyesight. Next slide, please. When we started looking carefully at the eyes of these birds, we noticed that some of them were cloudy. And so we started actually quantifying the degree of cloudiness or opacity in the lenses of these eyes. And started to notice, when you pay attention, when you look, you'll see that many of these birds have cataracts in their eyes, as well as other kinds of strange developmental abnormalities. Next slide, please. And so, in fact, a very strong relationship with background radiation. And there's no age effect. A young bird is just as likely to show a cataract as an old bird in these populations. Again, consistent with this being a radiation-induced result. And this paper was just published last month. Next slide, please. Interestingly enough, I just finished 2 weeks of collecting mice in the Chernobyl zone, and here's an example of a mouse with a very obvious cataract in one eye. And we'll see what kind of numbers we get in the coming weeks. Next slide. It's much easier when you can have control to see these things in the background. The next character of interest concerns fertility. In this case, male sperm, male fertility. We also notice that in populations of barn swallows in the contaminated areas, many of the sperm were deformed in strange ways. Next slide, please. In fact, in the areas of relatively high contamination, we see up to 40%. Some males have 40% of their sperm that are deformed. Next slide, please. And in fact, if you look at all the bird species, and we go to the red forest area, areas that are 1 to 200 microliters per hour, we see that up to 40% of the males have no sperm, or completely sterile. And again, this is consistent with what's been found in human populations, but it's never been seen in the animal populations. Next slide. This paper just came out yesterday in Biology Letters, and what it shows is that, very interestingly, this looks at sperm deformities for 10 species of birds, both in control areas in Europe, in Western Europe, versus Chernobyl areas. And what you can see here is that for each species, there's a much higher frequency of damaged sperm for these birds in the Chernobyl area, again pointing to the effects of radioactive contamination for 9 of 10 species that we looked at. Next slide, please. And we're going to sequence, let's see. My time is, well, that's okay. We've also been looking at barn swallows in Fukushima. Next slide, please. Barn swallows are a particularly useful bird to work with because of their tendency to build nests in accessible areas, including on top of alarm bells. This slide is entitled Barn Swallows Sound the Alarm for Radiation Effects in Fukushima. Next slide. What we've noticed in Fukushima is that for the first time anywhere else outside of Chernobyl, we're starting to see high frequencies of partial albinism in some of these birds. Again, only really reported in any significant numbers for Chernobyl, pointing to this as a good bioindicator of radiation effects. Next slide, please. Next slide, please. And this is just another shot from the Wild Bird Society as well, from contaminated areas. Next slide, please. And if we look at the frequency of reproduction in Fukushima, again, in areas of high contamination, you find that most of the birds disappeared. Most are not reproductively active when compared to control areas that are quite close by. And, I think, let's see, I think, I think at this point, I'll end with this picture here from Fukushima. And this is a picture of a field in the town of Namiya. It's a town very close to the reactor where the contamination levels were highest. And some grasses here. And you'll notice on the grasses here, these little bumps. These little bumps here are caterpillars. And when I first saw this area, I thought, great, I can collect insects. There are insects everywhere that I can capture and do genetic analysis on. Until I went to reach for these insects and realized these were all dead insects. These caterpillars had all crawled up and died on these grasses. In a normal situation, in a normal place, these caterpillars would have been eaten as they were dying by birds. But of course here there are very few birds. And so they have stayed there and mummified in place. And so it's actually everything we've looked at now in Fukushima suggests that it's an ecosystem in complete disarray. And